Okay, this is number 5 of physics shorts, and it's global heat flow, which is totally different than regular kitchen heat flow or other heat flows. And I've determined that since nobody actually watches this, that we are safe to go against the tomato sauce mob. So we're going to go over to the magic screen of physics and take my favorite physics tablet, and we'll start with global. Of course, we are going to go with the entire world, right? The world has an equator, and the sun is shining most of the time directly on the equator. This is, in fact, where probably 90% of our solar heat is created. Now we'll have the seasons, the winter and fall, but all of the heat comes from the equator, or our weather. So what happens is that the equator is getting very hot and it starts steaming off these huge plumes. And so we have to cover the fact of specific heat. So if a blob of air or anything, of little molecules vibrating, is moving, then the heat transferred is dependent on its specific heat and temperature, not just the temperature. So we could have a pickle ball with no heat energy, or we can have a very dense iron ball that has energy, heat energy. And in the world, water is at least 4,000 times more specific heat, a drop of water, than a drop of air. And if it's dry air, it's really that more than that. So that probably moist air, or heavily moist air, warm air, is carrying at least 1,000 times more heat energy than a dry air. So what is most important of these plumes coming up is that they are composed of moist air, and that is carrying pretty well all of the energy and most of our weather. The specifics will come later, but just know that temperature and specific heat comes with the total energy of a packet, and that these huge plumes are, when you look at them on the chart, we'll show that next, they are huge, complicated, big things, but you only see it horizontally. It takes little imagination to know that they are 3D and going through the whole atmosphere, so that all of our heat transferred around and moved around is through convection of moist air that is containing many more times, probably 1,000 by my calculations, of heat energy than the dry air. So we'll go back. That's long enough. And thank you for part 5, global heat flow.